Let's go and get started by working on practice exercise 27. So get your practice exercise booklets out. Yeah, I didn't figure. Get your practice exercise booklets out. And turn to practice exercise 27. You may use your calculators. You may use your calculators for this exercise. So practice exercise 27. And go and get started on that. Once you've finished, if you'll type done in the group chat, once you have finished practice exercise 27. Type done in the group chat once you finish. For those watching on YouTube, this is a Zoom session today, so the video is going to look very different. A little bit lower quality, unfortunately. Sound may be a little bit lower quality, but hopefully still beneficial for you. All right, Ethan, we are working on practice exercise number 27. Jamie, good to see you. She can't hear me now. She can hear me. Hi, Jamie. Good to see you. We are working on practice exercise 27 right now. Practice exercise 27. Hi there, Ethan. Ethan, I believe you have to use the chat. I've been told by other teachers that your audio's not, or your microphone's not working. Jamie, does your microphone work?
Okay, yes, it does.
All right, excellent. All right. So once you finish exercise 27, type done in the group chat. You may use your calculators for this exercise. Getting some practice using your calculator with decimals and fractions. All right, Genesis is finished.
Jamie's finished.
All right, for sake of time, we're going to go ahead and go over these now, and we'll give Genesis the chance to answer these first and see if she can get all the way through. If not, we'll go to Jamie. And Genesis, you'll go ahead and unmute your mic. Going across the top row, what did you get when you added those first two mixed numbers?
12 and 19 24.
Good, 12 and 19 24ths. For the next one, when you subtracted, you got
3 and 7 ninths.
3 and 7 ninths. And then the last one on that row?
2.
2 is correct. For the next row, going across.
0.0441.
Good. I'm usually lazy and don't write the 0 before the decimal, but 0.0441, absolutely. For the next one?
6.
6 is correct. And for the last one on that row?
15.415.
Good. 15.415. Next row going across?
3.46.
Good. I'm curious on this one, how many of you typed it into your calculator and then were like, oh, duh, divide by 10, move the decimal one place. Anyone like that? Yeah, a couple of you are like, oh, I could have done that so much more easily. It's all good. How about the next one, Genesis?
1.3272.
Excellent. For the next one on that row?
34.
34. All right, bottom row going across. What'd you get?
9 and 1/2.
Excellent.
4 and 11 twelfths.
Perfect. And for perfection?
10.
All right, here's the candy. Go ahead and catch. Just kidding. You can remind me, though, when you come back on Monday that I owe you some candy. Good job on that, Genesis. Anyone else get all of them correct? Jamie, you were next to. Were you perfect? You did. Excellent. All right. Any other questions? Anything like that? Anyone else perfect? Ethan says he was perfect on all the ones that he got done. Saw a nod from Chris there. Audrey also good. All right. Kendall also very, very good. All right, let's set those aside. Want to make sure we're good at using our calculators for some routine basic math. That's a good sign there. That said, let's get into our review of geometry. We got that exam coming up on Friday. Want to make sure we're ready to roll on that. Several lists of things that we need to be ready with. For instance, ways to prove two triangles are congruent. There's 5 different ways, and Kendall, if you could give me all 5 ways to prove triangles congruent.
Side, side, side. Side, angle, side. Angle, side, angle. Leg, leg, and leg angle.
And the last 2 that you said only work if you have previously stated in the proof that the triangle is a
Right triangle.
right triangle. Excellent job, Kendall. What about one of the best ways to prove lines and angles equal? Audrey. What is often a great way to prove that 2 lines or 2 angles are equal?
I don't remember.
Can you help her, Ethan? Oh, that's right. He's got to type it. You don't remember neither. Chris, help us out. One of the best ways to prove lines and angles equal is to blah, 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 blah.
Get angles equal.
To get lines or angles equal.
Is it?
To get congruent triangles and use CPCTE, often one of the best ways. Now, that assumes that the 2 lines or the 2 angles are in 2 different triangles you can get congruent. But often, one of the best ways to prove lines and angles equal is to get congruent triangles, use CPCTE. What if, though, I'm trying to prove 2 lines are equal and they're in the same triangle? Audrey, let's come back to you.
You said 2 lines in a triangle?
Right, to prove that 2 lines that are in the same triangle are equal to each other.
You get the opposite angles equal?
Good. If you can show that the opposite angles are equal, then those lines have to be equal. Ethan, what if I wanted to prove a couple of angles equal if they're in the same triangle? Want to prove a couple of angles equal and they're in the same triangle. Chris, help him.
I'm sorry, what was that?
How would I show that two angles are equal if they're in the same triangle?
Get two lines equal.
Which two lines?
Opposite.
The opposite sides, right? Get two sides equal. So if I had this triangle and I wanted to prove that, let's call the triangle MAC. And I wanted to prove that angle A equals angle C. What lines would have to be equal, Chris?
MC and AC?
MC and AC?
Yes.
That would prove that angle M and angle A are equal. I want an angle A equal to angle C.
So you would do, I'm drawing a blank. Is it, you would do,
If I want these two angles equal, what lines have to be equal?
M and A?
M is not M is a point. What line is across from angle C?
Angle, or side MA.
Side MA would need to be equal to side
MC.
MC. There we go. You get the opposite sides equal to each other. What if I wanted to get some angles equal and I knew that there were parallel lines in the picture somewhere? What are some different sets of angles, Jamie, that we could get equal to each other if lines are parallel?
Corresponding angles.
What about others? Oh, I think she's right.
Interior angles.
There we go. Alternate interior.
Exterior angles.
There we go. Alternate interior corresponding and alternate exterior. Great job, Jamie. What about some ways to prove that lines are parallel to each other? Kendall, give me one way to prove that two lines might be parallel.
If the alternate interior angles are equal.
Okay, good. If alternate interior angles are equal. Ethan, start typing one while Audrey gives me one.
If corresponding angles are equal.
All right, if corresponding angles are equal. Ethan's still typing. Chris, give me one.
If exterior, no, he already said that one.
He just said, well, and technically, Ethan, if alternate exterior angles are equal, okay, so if alternate exterior angles are equal, then yes, okay, Chris?
Did someone already say alternate interior?
Yeah, alternate interior was Jamie, I believe.
Okay.
No, she was the three, it was Kendall. Kendall was alternate interior. So alternate interior, corresponding alternate exterior. What's another way to get lines parallel?
Just interior?
No, Genesis. There's three more. All right, anybody unmute, call it out, or Ethan, type it in the chat. Ooh, if lines are,
yeah.
I heard it, Audrey, go ahead.
If lines are parallel to the same line.
Okay, good. If lines are parallel to the same line, they have got to be parallel to each other. What's another way? Somebody else.
Perpendicular.
If two lines are perpendicular to the same line. Good. And there's one last one. This one's a really obnoxious one to try to word. But remember, we said if the two interior angles on the same side of the transversal add up to a straight angle, then the lines would have to be parallel. So 6 ways to show that lines have to be parallel. We want to make sure that we know those. Another thing that we need to be very good with as we think about the exam coming up in a couple of days are your clanging statements. For instance, if I were given this line, let's just call it JN, and suppose that I knew that the midpoint was right here. Let's call the midpoint A. Jamie, what would have to be true if I'm told that A is the midpoint of JN?
JA and AM would be equal line segments.
Good. JA and AN are equal to each other. Let's see, what if I were told that, let's see here, I don't know, A, M, and GN. I suppose I knew that GN was perpendicular to AM. Audrey, what has to be true if GN is perpendicular to AM?
The angles at N are right angles.
Good. We could number maybe 1 and 2 and say that angle 1 and angle 2 are right angles. The angles at N are right angles. And Genesis, what's the implication if I know that these two angles are right angles?
Perpendicular.
Right, that if I knew I had right angles, then I would know they're perpendicular. Also, if in a proof you get a couple of angles to be right angles, you might be able to potentially say, okay, I've got some right triangles, or you may be able to just say, hey, they're equal, because all right angles are equal. What if we had an angle, and let's see here, maybe ETJ, and suppose we had a line BT, and we knew that BT bisects angle ETJ, forming a couple of angles. Let's call them 1 and 3. Ethan, what must be true? Angle 1 plus 3? Oh, angle 1 and 3 are equal. Good. Angle 1 and angle 3 are equal. You could also say, Chris, we could say, okay, angle 1 equals angle 3. Or we could say that angle 1 and angle 3 are equal.
Equal angles.
Well, they are equal angles, but if we had a bisector, we could say that these are each equal. There's a key word I'm looking for. Anybody? They're equal
Corresponding angles.
halves. They are equal halves of what is that, angle T, okay? And the equal halves thing was very important to us in a couple of proofs that we did, where we bisected two different angles, showed that the bisected pieces were equal halves, and then showed that the wholes were equal, so that the bisected pieces were halves of equals. And we were able to say that halves of equals were equal. We have this picture, an isosceles triangle. And we said that in any isosceles triangle, if you were to bisect the vertex angle, this line that bisects the vertex angle is going to have two other things true about it. Jamie, do you remember one of the, or maybe both of the things that are true about the line that bisects the vertex angle of an isosceles triangle?
I'm not sure.
Kendall, can you help?
Is it perpendicular to the base?
Good, it's going to be perpendicular to the base. Do you remember the other one?
No.
Genesis,
I
can
got
you
it.
help?
That the two triangles are congruent.
Well, we didn't necessarily go that far, though they would end up being congruent, yes. Ethan, I think, looks like he hinted at it in the comments there. It'll also bisect the base. So the line that bisects the vertex angle, we proved will bisect the base and will be perpendicular to the base. We also proved that in any isosceles triangle, if you were to draw a line to the midpoint of the base, so you got an isosceles triangle, if you draw a line to the midpoint, two other things have to be true about the line that goes to the midpoint. Jamie, can you give me one of the things that's true of this line?
It would be perpendicular,
Good. Can you give me the other one? It's going to be perpendicular to the base.
and it'll bisect the base.
Well, we already said it goes to the midpoint. So yeah, we already kind of knew it bisected the base.
The line segments on either side are equal.
Well, yeah, because it's a midpoint, but that's not true about the line itself. Audrey, can you help her?
Does it bisect the angle?
Good, it'll bisect the vertex angle as well. So if it bisects the vertex angle, listen, if it bisects the vertex angle, then it bisects the base and is perpendicular to it. If it goes to the midpoint of the base, in other words, if it bisects the base, then it bisects the vertex angle and is perpendicular to the base. What do you suppose would have to be true if we had an isosceles triangle and we were to draw a line that was perpendicular to the base? That is a line that is an altitude on the base. What two things do you suppose would have to be true then? Genesis?
It's a right triangle.
Well, it would form right triangles, that's true, but what's true, would be true about the line itself? If it's perpendicular to the base, then it
Bisects the base.
it'll bisect the base.
Okay.
And Chris, take the other one.
We'll bisect the angle.
It'll bisect the vertex angle. So you see that one line does all three things. It just depends on which thing you know. We've proven the other ones. Another thing that we need to be able to do on the exam on Friday, we need to be able to work with parallel lines and those equal angles that are formed. Let's suppose we had a couple of lines here that are parallel to each other. And supposing we had some picture like this. So let's suppose we've got lines A and B are parallel. Let's number these angles 1, 2, 3, 4, 5, 6, 7, 8. Actually, take just a couple of moments. If I know that angle 1 is, let's say, 54 degrees, and if I knew that, let's say we knew that angle 7 was, that's kind of small, let's say 32 degrees. I want you to find the other angles. Take a few moments to work this at your seats. Type done in the group chat once you're finished. So finding angles 2, 3, 4, 5, 6, and 8. Sorry about the video there, Ethan. I'm not quite sure what the deal is. Must be home internet. Oh, shoot, I was supposed to be recording. Oh, I am recording. Yeah, I'm recording this, Ethan. So if you're having trouble, you can go on YouTube in about an hour, and you can rewatch if you need to get the parts that you missed. For a minute, I was afraid that I hadn't started the recording, but I did. All right, Genesis is finished. All right, Jamie's finished. Hi, Genesis. I can see you. Ladies who are already finished, if you wanted to kind of be skimming your notebooks, looking over terms and definitions, using your time profitably while we wait for others to catch up to you, that would be a good use of time. We will get to reviewing those in just a little bit, and we can't do our usual review game with them, I'm afraid, but still, the study would serve you well on Friday. Take about 2 more minutes to finish up if you're still working. Again, let me know when you're finished by typing done in the group chat. All right, Ethan's done. There we go. I was hoping the 4 girls wouldn't beat the 2 guys. That would be embarrassing. So good guy in there. All right, Audrey's done. Kendall's done. You just made it, Ethan. Girls almost had a 1 through 4 sweep. And, oh, sorry, I thought I saw it. I was like, oh, and Chris is done. No, that was you saying hello. Threw me off, Ethan. Chris is stuck. All right, let's go ahead and take a look at these here. Tell you what, Chris, if you'll go ahead and unmute your microphone and assuming that stuck didn't mean like the video is stuck, assuming stuck meaning you're a little bit confused on how to proceed, let's go ahead and take a look at these together and see if I can help unstuck you. First thing I would do is label directly on the picture the angles that I know. I know that angle 1 is 54. I know that angle 7 is 32 degrees. Now, again, in working these, Chris, you don't solve them in order. You go with whatever you see first. What angle do you see just like that?
I don't. Is that 5? In front.
Right here?
Yeah.
That's a 5.
Yeah, that'd be 32, right?
Right. Angle 5 is 32 degrees. Let's go ahead and get that one out of the way real quick. And we can even replace the 5 with the 32 now that we're done with it if we'd like. Okay?
2 is 54
Why is 2 54 degrees?
because there's a bisector.
Did it say there was a bisector?
Our eyes can deceive us. 3 because it's alternate interior, so it would be 54.
3 is alternate interior to what?
The 54, angle 1.
To the 54?
Yeah.
Those are alternate interior angles?
No.
Well, if we're looking at these 2 lines as my parallels, Chris, and this might be why you're stuck. 54 isn't interior, 54 is exterior, right? It's outside the lines. 3 technically isn't even an angle because is 3 formed by either one of these lines?
No.
No, so 3 is not even an interior angle. So no, we're not going to go that route.
It doesn't say all, so we just need a perpendicular or a parallel to B.
I
So
can't hear you,
that's
sorry.
all we get is a perpendicular to B.
No, A is parallel to B. That's all we're
Parallel,
getting.
my bad,
A is
my bad.
parallel to B, then angle 1 is 54, and angle 7 is 32 degrees.
Angle 2 is 32
Why is angle 2 32?
because they're opposite interior or opposite.
This time we really do. Do you see how these really are alternate interior, Chris? They're between the lines and they're on opposite sides of the exact same transversal. So I'm going to just put a little 3 in front of the 2 here. And angle 2 really is 32 degrees. Good. All right.
Um, 54 is equal to 6.
Good. These 2 angles are what kind of angles, Chris?
Aren't they corresponding?
Good. They're both on the same side of there. Now it's a different transversal than we use for these 2 alternate interior. Those use this transversal, which we could call S. This transversal, maybe we call it T. These are on the same side of transversal T. They're both above their respective lines. So 6 has to also be 54 degrees. Excellent. All right.
So couldn't we get 3 just by adding 32 to 54 and minusing from 180 technically?
Absolutely. Either because of the triangle that's formed here, or because of the straight angle that's formed right here at this point, right? The sum of all the angles about a point equals a straight angle. So what do we get for angle 3?
94.
Good, ends up coming to 94 degrees. And again, it's not drawn to scale. It certainly doesn't look like a 94, but we don't trust our eyes anyway. All right, just 2 to go.
Let's see here. We don't have that. Four and 8 are both obtuse, right?
They appear to be obtuse, yes.
Right. And those are the only 2 obtuses we have.
Well, technically, this angle right here is obtuse also. It's 94 degrees. It certainly doesn't look obtuse, but we don't trust our eyes.
Right. What it would be 4 would be 32, would it not?
Would it be 32?
Yeah,
Why?
because it's on the same transversal line, isn't it?
So these two are on the same transversal,
No,
right?
I was saying 7 would be equal to 3 to 4, but yeah,
Oh, these two are both going to be the same angle.
right. Yes, that's what
Are-
I'm thinking.
Looks to me like together they should add up to a straight angle.
Oh, that's true. Ooh, that's true. So 148 would be what it is.
There we go. We should get 148 for angle 4.
So then 8 equals 148 as well.
Also equals 148 degrees. All right. So question is, he got him. How'd the rest of you do? Ethan says he was perfect. Jamie was perfect. Audrey missed 2. Which 2 did you miss, Audrey, while the other answers come in? Which 2?
I missed 3 and I missed 6.
And angle 6. What did you have for angle 6, first of all?
I don't know. I changed it. So
Oh, okay. Do you remember what you had for 3?
I think I put 32.
Oh, okay. So you treated this like maybe a bisector at 32 and 32. And then that would have affected perhaps angle 6. Does it make sense that 6 is 54 because it's corresponding to the given 54?
Yes.
All right. And then again, here you've got the straight angle. You just add up the 180, or again, look within the triangle at the 180. All right. Kendall also missed 2. Kendall, which 2?
Number 3 and number 4.
Number 3, which was this one, and number 4, which was this one. So you got number 8 to be 148 degrees, Kendall?
Yes.
And so even though these were vertical, you said that they were different sizes?
Yeah, I forgot to look at that.
What did you have for your angle 4?
I had 54.
Did you look at these 2 as if they were corresponding?
Yeah.
All right, do you see how 54 is formed by transversal T, and this angle is formed by transversal S? So 2 different transversals, so they couldn't be. Does that make sense now?
Mhm.
Okay, and then you said
Yeah.
angle 3. What did you have for angle 3?
I had 32.
So again, kind of like Audrey, you were looking at perhaps these 2 angles together or something, or maybe these 2 angles. What was your thought behind the 32? Do you remember?
The 2 angles, angle 2 and angle 3 together.
Right here?
Yeah.
You just said that they were both going to be 32?
Yeah.
Kind of envisioning a bisector like Chris had envisioned?
Yeah.
Yeah, be careful not to envision those. You go with straight angles, triangles, and of course your alternate to your alternate to your corresponding. Let's see, Genesis, you said that you missed two also. Which two did you miss, Genesis?
2 and 3.
2 and 3. All right, so everything else was perfect. What did you have for angle 2?
54.
So you pulled a Chris and you went with this bisected look. Is that right?
Yeah.
Okay. And so then what was your angle right here at angle 3 then?
54.
Oh, wow. So you just went, they're all equal to each other. Okay, careful on that. Careful there. Tell you what, let's do one more. Since we seem to have some struggles with it, let's do another one. Make sure we've got this down pretty well. Because I really haven't had a chance to work with you on this. I've had a chance to show a few of these, right? Yeah, never pull it, Chris. You haven't had a chance to actually work with you on these much. So let's suppose we've got this transversal here and transversal here and a transversal here. Okay, and we'll say that there's M and there's N, and we're given that M is parallel to N. I've got angles 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This should be a doozy. All right. Ethan's crying. All right. Let's suppose for a moment that we knew that angle 10 is, that's a nice big angle. Let's call it 140 degrees. And let's suppose I know that angle 2 also looks like a nice big angle. Let's say that's 110 degrees. And let's see here. Let's suppose I know that angle 14 is 60 degrees. Go ahead and find the other angles here. Give me just a minute to get out of the way. And your strategy, very simply, is find all of them as you can, one at a time. Of course, you're certainly welcome to use a calculator if you need one. It looks like we lost Genesis. She's like, no, you gonna give us one this big? I'm out of here. Forget this. No, surely that's not the case. Surely it was an internet glitch. Ethan's finished. Tell you what, for sake of time, since the class period's almost over, let's go ahead and go over some answers here and see how we could have, should have done this. Looks like James also finished. Let's start with Ethan. Ethan, just give me any one of the angles, or perhaps the first angle that you would have found, given that we had 140 degrees here, that we had 110 degrees here, and that we had 60 degrees here. What's the first angle you found? Angle 1 is 70. Good. I like the supplementary relationship right here at the top. If this is 110, angle 1 must be 70. All right, Jamie, give me an angle that you found next.
Angle 13 is 40 because of supplementary.
Good, because of the supplementary relationship, angle 13 must be 40 degrees. All right, Chris, give me an angle we can find next.
I got 7 was 110.
How much?
110.
All right, and you said that these two angles are corresponding?
Yes.
They are corresponding, but are their lines parallel?
No.
No, technically together, 7 and 8 together would have to be 110 because these are the parallels. Let's take a different angle then.
I got that 11 is 140.
How did you get 140 right here?
I thought because of it being a bisector.
Where does it say bisector? Did I ever say the word? Did I write it down?
No.
No, don't assume there's a bisector if it's not said. But there is another angle that'd be very easy to find.
12.
I'm sorry?
12.
Okay, I don't think
no,
that's easy to
angle
find
4.
at all, actually.
Angle-
12 is
angle
not
4.
easy.
Angle 4.
Angle which one?
4.
Angle 4? How big is angle 4?
70.
There we go. Get an easy one, right? Get the vertical angle in there. Let's go to Kendall.
Angle 3 equals 110.
Yeah, let's get another easy angle in there. 110 for angle 3. All right, Ethan, let's come back to you now. Wait a second, I skipped somebody. Audrey. I skipped Audrey. Audrey, give me an angle. I'm so sorry. I'm like, I should have 5 of these. I'm so sorry, Audrey. You even have a beautiful volleyball picture, and I still skipped you.
11 is 40.
Now be careful. Are these two angles vertical angles?
I guess not.
Well, think about it. These are the two lines that make up 40. These are the two lines that make up 11. Now, one of their lines is the same, but you see it actually takes 3 lines, not 2 lines. So vertical angles are formed when 2 straight lines intersect. But there's an easy angle we can get. In fact, there's a couple of easy angles we can get. A couple of alternate interior angles we could get. What would be alternate interior to this 40-degree angle?
8.
8 would be alternate interior. So 8 then must be 40 degrees. Let's see. Ethan, you gave me something then. You said angle 7 is 70. And I believe, Ethan, you were looking at this triangle right here. And you said, well, I've got 40 and 70. That's 110 degrees so far. That leaves 70 degrees for angle 7. Another way we could look at it, Chris, remember we said that this is 110 and this must also be 110, right? They're corresponding angles. Well, since now that Audrey told us this was 40, if there's 110 here, that leaves 70, which means, by the way, we've got a little isosceles triangle there. Yeah, 70 degrees for angle 7. There's still another
80.
relatively easy angle we could get. Let's come back to Jamie.
Another angle, let me look. Would 5 be 40?
Good. 5 would be a vertical angle because notice this time, Audrey, it's the same two lines that form the 40 and angle 5. So angle 5 now has to be 40 degrees. Or you could look at it as these two angles here and here are both below the respective lines and to the left side of this transversal. So these two angles are corresponding angles. So angle 5 is 40. Excellent. Chris, we've got a couple of easy options on the table now.
Angle 12 is 100
Oh, how do we get 100?
because you got 40 and you got 60, so you add them together, you get 100. It's 80, my bad, 80.
There we go, 80. You were thinking the right thing, right? You were thinking of this triangle right here. We have 100 degrees so far. That leaves 80 degrees for angle 12. Excellent choice. Let's see, Kendall, give me another one.
Angle 15 is 60.
How did you get 60?
Corresponding.
It's corresponding to what?
To 60. No.
It's actually corresponding to this one here, right? It's below the line and to this side of the transversal. So this whole thing here is corresponding to 15 here. Or perhaps a better way to be would say, hey, look, we've got a straight angle right there at that vertex. Right, this
So
one.
would it be 120?
Good. Number 15 should actually be 120 degrees. All right, Audrey. We got 3 angles on the table.
Angle 6 is 70.
Good. A couple ways you could have got this, but perhaps the easy way is to look at these two angles right here and say their alternate interior, 6, has to be 70 degrees. You could also take the straight angle right here, or the fact that these two angles have to add up to a straight angle. So a number of ways in which you could have gotten 70 for angle 6. There's 9 and 11 left on the table. Ethan, take 9 or 11. Okay, 9 is 140 degrees. Good. Notice these two angles together have to be a straight angle. We've got 40 right here. That leaves 140 in the 9 spot. And for angle 11, Jamie, finish this out.
100?
Good, because again, we've got this straight angle right here on this side of the line. 80 here, that leaves 100 degrees for angle 11. This is way harder, by the way, than anything we'd have to do on the exam on Friday. Okay, so don't panic too much over it. It won't be this complicated. Okay, we have 3 different transversals going at once. But how did we do? I'm curious, did anyone get all of them perfect? I am curious. Ethan thinks it's pretty easy. He got all of them. Okay, good. That just means that God's wired your brain to think that way, and that's happy. Okay, Jamie missed 2. All right, that's not too bad at all out of 15 angles. Well, 12 angles that you had to find. So 10 out of 12 is not bad at all, Jamie. All right.
I missed 4.
Missed how many?
4.
4? Okay, that's not too shabby. The big thing, do we understand the 4 that we missed, or Jamie, the 2 that you missed?
Yes, sir.
All right. Making a little bit more sense, Chris. I know it was a really, really hard, big, ugly one, but as we went over more and more of them, did it help you to understand the process better?
Yes, sir.
All right, good. Audrey, Kendall, waiting on some feedback from you two ladies. Audrey missed 5, but Kendall missed 3. Okay, that's not too bad. Do we understand how to look at the pictures now, Audrey, Kendall?
Yeah.
All right. Kendall feels pretty confident, and Audrey gives me a yup. All right. Tomorrow in our review, we're going to review over your constructions. It wouldn't hurt for you to look that over tonight. Make sure you're ready to go with those. Also, we're going to drill over some terms definitions, informal statements, axioms, postulates, a lot of the memorized stuff that you need to know. Okay, so spend some time studying tonight. Tomorrow we'll review over it, and then Friday is our exam. Don't forget your notebooks are due on Monday when you return to school. Of course, we'll look at your exams on Monday when you get back also. All right, if you have any questions, make sure you have your parents email me. Otherwise, have a great rest of your day.